In the second part of the atomic masses, we talk about the average atomic mass. If we look at the periodic table, we can see that all the atoms have a mass, like for nitrogen, for example, or carbon. Here we can see that the mass of the carbon is 12.0107 gram per mole, or AMU. Indeed, gram per mole is equivalent to atomic mass unit. Here the mass of the carbon does not represent the sum of its subatomic particles. Indeed, carbon contains 6 protons and 6 neutrons. So the sum of these subatomic particles gives a number of 12 AMU. But on the periodic table we have 12.0107, and it's the case for almost all the atoms. For example, the bohr is 10.811 and silicium or lithium. The reason for that is that the masses that we have here on the periodic table are average masses. So the masses that we have on the periodic table are an average atomic mass. This average atomic mass is the mass of a mixture of stable isotopes. So it represents the average of the mixture of stable isotopes. For example, carbon has 2 stable isotopes, C12 and C13. The C12, which is present which has a percentage abundance of 98.89%, has a mass of 12.0 AMU, and the isotope C13, which has a percent abundance of 1.11%, has a mass of 13.0055 or 335 atomic mass unit. So the mass of the carbon, the average mass of the carbon is just the atomic mass unit of each isotopes by multiplying it by the mass fraction. Here we have 98.89% over 100% plus 13.00335 AMU times its mass fraction, which is 111% over 100%. And the average atomic mass of carbon is equal to 12.01 atomic mass unit, which is the same as in the periodic table, 12.01. So we can see why the atomic mass is different from the sum of the subatomic particles. We can also add that the atomic mass unit that we have in the periodic table is always close to the most abundant isotope. For example, here 12.01 is very close to the mass of the most abundant isotope, which is C12, because it is present at 98% in nature. Let's do another example. Naturally occurring bromine consists of 2 isotopes that are bromine 79 and bromine 81. So each bromine has this exact mass in atomic mass unit, 78 and 80, with their relative percent abundance. We can see here that the percent abundance is almost 50% for each one. So they are occurring naturally with the same abundance. What is the average mass of the bromine. So the average mass is just the atomic mass unit of each isotope. Here we start by the first isotope 79, so 78.9183 AMU times is its mass fraction, which is equal to 0.5069, plus here we have the first isotope, bromine 79. The second isotope is equal to 80.9163 AMU times its mass fraction, which is equal to 0.4931. Here, the second part of this equation is relative to the bromine 81. And the result is 79.90 AMU, which is the average mass of the mixture of stable isotopes. We can see here that 79.90 is halfway between the two exact mass. Indeed, the first isotope, which is bromine 79, has a mass of 78.9 atomic mass unit, and the second, here the first isotope, bromine 79, and the second isotope, which is bromine 81, has a atomic mass unit of 80.9. So it was expected to have an average mass of 79, which is halfway between both, because both isotopes exist have a percent abundance of almost 50%. So the average mass is between these two values.